Hey guys, I hope you all are doing good. If you remember, in the last lecture, we covered predicates and quantifiers, right? In this one, we will be covering what is logical equivalence, and we will also try to understand how to basically simplify logical statements, right? So this is going to be very important to understand. Just like we simplify equations in mathematics, we also try to simplify equations in, or I should say, logical statements as well, right? We're going to learn how to compare different truth tables or how to find what is the equivalence of different statements. So let's start with the first definition, right? Two logical statements are logically equivalent if they have the same truth value in all possible cases, right? So I'll try to explain it with a very simple example, right? Think about, I have this proposition P then Q. If you remember, this is the if statement, right? The conditional statement which says if P is true, then Q is true, right? Now, if I say this is equivalent to negation of P or Q, what I'm trying to say is for any value that I input in this P and Q, the resulting value should be same, right? Let's try to understand with the example, right? So let's say if I say P is true and Q is also true, and over here is the same, then if you notice, their answers are also going to be same, right? This is going to result in true gives true, right? The final answer is going to be true. And in this case as well, negation of P or Q, which means false or true, is going to result in a true as well, right? So they are equivalent. Now, if I take the case where P is true and Q is false, right? Same thing happens. If P is true and Q is false, I get false in this case, right? If you remember from the table of conditional statements, and in this case as well, I get false or false, which results in a false again. So what I'm trying to say is, whatever value I input into P, let's say P is supposed to be true and Q is supposed to be true, these two equations will result in the same answer. It could be either true or it could be the false, right? So this is what equivalence basically means. And if this happens for basically a condition or a logical statements, then we basically say they're logically equivalent, right? So I hope you're able to understand the basic concept of how logical equivalence works. Now, thing is that we need to check the logical equivalence, right? That is going to be very important to understand. So this is a very important question that you could get in your exams, or in general, you could be asked if the two statements are logically equivalent, right? So we have two ways of finding out whether two logical statements are equivalent or not, right? One is using the truth tables, and the second one is the symbolic manipulation. Now, I've used a very hi-fi word in this case, but I'll try to explain it in very simple, right? In very simple words, this is basically just trying to simplify the statements, right? Using the laws that I'm going to introduce in this video, and then try to figure out that both the equations are exactly the same, right? Okay, let's take a look at two examples for both these cases, right? So for the truth tables, let's say I need to prove is equivalent to negation of P or Q. Let's say I need to prove this point, right? That both these equations are equivalent. So what I can do is I can use the truth tables that I have, which is I'm going to draw P, Q, P then Q, and negation of P or Q, right? Now, we already know that there are four possible cases, right? Because 2 multiplied by 2 basically results in 4. Now, I'll try to explain this concept in the future as well, how we try to figure out what are going to be the number of inputs. But for now, let's try to understand that there are going to be 4 inputs in this case, right? So, what are the 4 inputs? One input could be true value for both P and Q. One could be true false, where P is true, Q is false. One could be P is false and Q is true. And final could be both are false, right? So these are the 4 possible inputs that we have. Now let's try to see what are the results that we get in P then Q and the negation of P or Q statement, right? When both are true, we get true and true, right? When this is true and this is false, we get false, false in this case as well. When P is false and Q is true, we get true in this case, and we get true in this case as well. And when both are false, we get true in both the cases, right? So if you notice, their truth values are equal to each other, right, for all the cases. So when P and Q are true, they are equivalent, right? Both are true, both are false. So they're basically equivalent to each other, right? And this way, I've basically proved using the truth tables that both these logical statements are equivalent to each other. Now, this is a very good way to solve when the equations are pretty small, right? So for example, this one is a very small equation. So if you have, let's say, an equation with 3 or 4 variables, I think you'll still be able to use truth tables to prove whether they're equivalent or not. But the problem comes when the equations are extremely long, right? So you could get an equation which is maybe 4 or 5, maybe 5 or 6 different propositional statements that we have, and then that becomes very tough to draw all the truth tables and then compare all the truth values, right? So in that case, we basically use symbolic manipulation. The basic point is, if I have a very big truth statement, then what I can do is I can try to simplify it down, right, to a small statement. Maybe both the sides I can simplify and then compare them. If they are equivalent to each other, then I would say that they are logically equivalent, otherwise they're not, right? So let's try to see a basic example of this case as well. Let's say I need to prove negation of P or Q is equivalent to negation of P and negation of Q. Now, in this case as well, since we only have two variables, it is still very convenient to use the truth tables. But in this case, I'm going to use the symbolic manipulation, right? So I'm going to use the laws which I'll introduce in this video, in later in this video. But for now, I need to prove this point, right? Now, if you try to remember, this is very similar to a concept that we have already covered in the sets concept, right? What this basically means is, so since I need to prove this, I'll try to convert this statement into this part, or maybe I'll try to do the vice versa, right? So let's start with this portion over here, which is the left hand side, right? Given P or Q, what I can do is I remember that there's a law that exists in propositions, right? Don't worry about the laws as of now. I'm just trying to give an example of how this works, right? So what I can say is, using the De Morgan's law, I get this is equivalent to negation of P and negation of Q using De Morgan's. Hence, LHS equal RHS, right? This is a very small and very basic example. Basically, what I did is I had to prove that they are logically equivalent. So what I did is I did I used this equation and I used the De Morgan's law, right? And using the De Morgan's law, we already know that these two statements should be equivalent, right? And that is why finally I wrote down that left hand side is equal to the right hand side, right? This is kind of very similar to the way we work in mathematics as well, right? We have laws, we use those laws, maybe the commutative associative laws, and try to prove whether two equations are equivalent to each other, right? And this is kind of pretty much the same, but with a few differences, right? Okay, so I hope you were able to understand basically what is logical equivalence and how do we prove whether two statements are logically equivalent, right? Now let's try to understand three different concepts, which is tautology, contradiction, and contingency. Okay, now let's try to understand what is a tautology and what is a contradiction and a contingency, right? These are very basic to understand. So a tautology is basically a statement that is always true, right? The basic point is it is basically a logical statement that such that whatever inputs I put into it, it always results in a true value, right? So whether I input a true or a false value, it's always going to result in a true. Let's take a look at a very basic example, right? A very basic example would be P or negation of P, right? So I've already written down these over here. When P is true, we know negation of P is going to be false. And when P is false, we know that negation of P is going to be true, right? These are the only possible inputs that I have. So when P is true, negation of P is going to be false. And when P is false, negation of P is going to be true, right? Now think about it, right? When the statement is true or false, it should be true, and when it's false or true, it should be true again. So doesn't matter if I input true or false into the value p, it always results in a true value, right? So this is a basic example of a tautology, right? What is a contradiction? A statement that is always false. Statement always false means, let's say whatever variables that I have, p, q, and whatever logical statement I have, any inputs that I put in, it always results in a false value, right? So just like basically the opposite of this over here. Example in this case can be q and negation of q, right? So let's take a look at this example now. Okay, first let's try to understand how many number of inputs do I have, right? I can either input true or a false value into q. So when I input true into q, negation of q is going to be false, and when q is false, negation of q is going to be true, right? Okay, when I do true and false, we know that in the and statement we need both the conditions to be true, right? So in this case it is going to be false, and same thing happens in this case as well. So what the basic point is, if you compare both of these, in this case whatever value I input into p, it results in a true value, and in this case whatever value I input into q, it results in a false value, right? So whenever the values are true, we say it's a tautology. Whenever they are false, we say it's a contradiction, right? Finally, we have a statement that can be true or false based on the input. Now this is the statement that we have been looking so far in our lectures, right? So it can be true or it can be false. A very basic example could be just the conditional statement. Based on the inputs, it can either be true or it can be false, right? So I hope you were able to understand what is a tautology, what is a contradiction, and what is a contingency. Moving on, now let's try to understand the most important part of this video, which is how to simplify logical statements, right? So let's start with that part. Okay, now let's try to understand the important logical equivalences, right? Just like I said, these are going to be extremely important to understand and remember when you are supposed to solve logical equivalence questions, right? As we move on, even through the future courses that you might take throughout your university, such as data structures, or sorry, I should say databases, you will be trying to understand or using these type of equations to prove equivalences, right? So very important to understand. So let's start with the first law, right? Once again, these are the same laws that we covered in the sets as well, right? So if you find any confusion in these laws, try to move back to the sets and cover the lecture. I'll give the lecture link in the description, and I've covered all these laws in that lecture as well, right? So but in this video I'll try to cover them in much detail as possible. So starting with, we have the identity and the domination laws, right? What are the identity and domination laws? Try to understand in very simple words. When we talk about identity, think about that we are trying to maintain our identity. If somebody is trying to attack us or trying to change us, we don't let that happen. We maintain that identity. Domination is that somebody is trying to dominate us and make any change with us, right? So if you look at these two examples, right? If you look at the identity examples, P and true is always going to be equivalent to P, right? So P is maintaining its identity in this case, and P or false is going to be equivalent to P, right? In both the cases, P is trying to maintain its identity, right? And if you try to understand what this means, right? P and true, right? When it comes to and statement, we say all the statements need to be true, right? Why is this equivalent to P? Because the answer to this logical equivalence over here depends on the value of P. If P is true, then this would be true, and if P is false, then this would be false, right? In this case, we know that in an or statement, only one of the conditions needs to be true, right? So we already have that one condition is already false. So now the answer depends on the P over here. If P is true, then this is going to be true, and if it's false, then it's going to be false, right? So basically, P is maintaining its identity, and it doesn't matter whatever it gets affected by, it still tries to maintain it, right? In the case of domination, P is getting dominated by the other value, right? So P or true results in true. So this true is dominating P over here, and this false is dominating P in this case, right? Okay. Moving on, double negation is very easy to understand. Basically, if P is true, then the negation of P is going to be false, and if I negate it one more time, then it's going to result in P again, right? So basically, when we negate P two times, it gives us the P value back again. Okay, moving on. Very important laws. Let's try to understand what are the De Morgan's laws, right? These are going to be very important to understand and remember because we extensively use these laws in a lot of questions, right? Very basic to understand. Basically, when I negate P or Q, then when I try to open those brackets, we change all the signs inside, right? So I negate P, this or I should say, or disjunction changes to conjunction, and then I negate Q as well. And the same thing happens in this case, right? So we basically do the opposite of whatever's happening inside the brackets. This is kind of just like if I do minus of 2 plus 3, then I would do negative of 2 and negative of 3. Basically change the signs that we have, right? And it kind of works in that way. Okay, moving on. Let's try to understand the distributive laws, right? Distributive law, if you remember, right, this is how an equation works. 2 multiplied by 3 plus 2. In math, this basically means 2 multiplied by 3 plus 2 multiplied by 2, right? And that is exactly how distributive laws work in this case as well. The basic idea is, but in this case, the difference is that while only multiplication is distributive over addition, in this case, both the conjunction and disjunction are distributive over each other, right? Once again, in this case, in the case of propositions, both the conjunction and disjunction are distributive over each other, right? So let's try to understand what it means. If you look at the statements over here, when I do P or, when I in the brackets I have P, Q, and R, you can see that this is kind of just like the distributive statement that I wrote down over there, right? And same thing happens in this case as well. So the disjunction is distributive over conjunction in this case, and the conjunction is distributive over disjunction in this case, right? We also have two more laws that I haven't written in down over here, but they are very easy to understand. One is the commutative laws, and one is the associative laws, right? Both of which I think are very easy to understand and shouldn't be a problem if you understand them. Okay. Fifth one, let's try to understand what are the absorption laws, right? These two are also going to be very important to understand. Basically, when I do P or, when I do P or P and Q, it results in a P. And when I do P and P or Q, it results in a P once again. So I've tried to explain these in the sets video very well, right? I would like you guys, if you don't understand how the absorption laws work in detail, try to watch that video, and I think you'll be able to understand very clearly what this means, right? Okay, moving on. The last one is the negation laws. Negation laws we have already covered in this video only, right? When I try to explain what is a tautology and what is a contradiction, I use these two examples to explain it, right? The basic idea is, in an OR case, we know that only one needs to be a true value. So when I do negation of P with P or P, we know that one of these has to be true, right? Either negation of P has to be true or P has to be true. So the equivalence is going to be true. And in this case, we know in an AND condition, both the conditions need to be true, right? But we know one of them is supposed to be false, and hence the final result is false, right? So I hope you were able to understand all these laws in detail, right? Once again, the laws that I missed are the commutative laws, which is basically means I can arrange the elements in any order I want. And the second is the associative laws. Basically, I can change the arrangement of the brackets, right? Okay. Now, if you have a good understanding about these, now let's try to solve a very basic example of a simplification of a logical equivalence. Okay. So I've given a very simple question in this case, right? We need to prove that this side, this entire equation is equivalent to negation of P, right? Now, obviously, just like I said, there are two ways to do it. One is I can draw the truth tables for the entire equation, and try to prove whether they are equivalent or not. The only problem is I have so many variables that I need to form truth and false values, then solve the equation on both the sides, and then figure out and compare both their values, right? While it can be easy to do in a computer, this is not very efficient when I'm trying to do it manually, right? So let's try to do it using the laws that we covered just now. So given, I'm going to start from the left hand side. So negation of P or Q, or negation of P and negation of Q, right? So I'm going to try to see if there's any law that I can use over here. And the one law that I notice very clearly is in this side, right? And the law is the De Morgan's law. So if I try to use the De Morgan's law, I get negation of P and negation of Q, or negation of P and negation of Q, right? This is exactly what I get. And I'm going to mention the law that I've used, right? So using De Morgan's. Okay. So now, if you notice very clearly, this is negation of P and Q, or negation of P and negation of Q. This is like actually the distributive law, right? So what I get is I can take this negation of P common, right? And then I get negation of P and Q, or negation of Q in this case, right? Using distributive laws, right? So what I did is I took this negation of P common. If you try to remember the distributive law statement, right? This is basically the part which is on the right hand side of the equation. So I took both the values common, negation of P, then I took the and then the resulting value in the brackets I get is Q, or negation of Q. Now, if you remember, there's one more law in this case, right? Q, or negation of Q. This thing has one specific equivalence value, which is actually true, right? So this is the negation law. Q and Q, or negation of Q, is always going to be equivalent to true. So I'm going to use that now. This gives me negation of P and true in this case. Remember, if you have any question in your exam or something, try to mention all the laws that you've been using. Even if you've not been asked to do it, it's just a general good way to understand what exactly you've been doing when you try to remember or understand if you have done everything correctly or not, right? So using negation, right? Now finally, I have the statement negation of P and true. Okay, so try to understand in detail, right? Whenever there's an and in between, that basically means I need both the conditions to be true, right? But since I already know the right hand side, or this part is true, that means that this negation of P is what the actual answer depends on, right? So this negation of P can be either true or it can be false. So the final answer is negation of P. And what is this law again? This is going to be the identity law, right? Why? Because negation of P has maintained its identity, even when something, or I should say some element, tried to manipulate it. So using identity. So we started from this large equation and went on to this. And finally, I can say hence, right? So I hope you were able to solve this question. Now, a simple activity I can ask you guys to do is try to solve it using the truth tables, right? Not a very good exercise, to be honest, but I think it would be easy to understand, and it would be a good way to understand how these things work, right? Now, I'll be giving a bunch of questions, just like every video, and I want you guys to solve it, and then I'll try to solve those questions myself. Okay, so I hope you have solved all these questions. Now, I'm going to leave the first question. It's basically you just have to write the truth tables, and if you understand what is tautology, contradiction, and contingency, then it should be very easy to understand, right? I'll give you a basic hint. You need to draw all the truth tables, and then if the final answer results in a true, all the values result in true, then it is going to be a tautology. If they're all false, then it is going to be a contradiction, and if they are all either true or false, then it is going to be a contingency, right? So once again, write the truth values for PQ, solve these equations, and figure out what they are, right? Either tautology, contradiction, or contingency. Okay, moving on. Let's try to understand question number 2, right? Simplify using the De Morgan's law. So I've been given this statement over here. If you understand the De Morgan's law, how it works, basically what I'm supposed to do is I have this negation sign outside. I'm supposed to bring it inside and apply it to all these different parts. So I'm going to apply this negation to negation of P. I'm going to change this symbol, and then I'm going to apply it to this part as well. So let's see how it works, right? So this gives me negation of P. This sign changes to OR, and then I need to apply the negation to next equation as well. Right, so this is what I get. Now, if you understand this equation, right, I have this negation of Q or negation of R. This basically means that I need to apply the De Morgan's law once again, right, to simplify it further down. So let's try to figure it out. Since this is negation of P, this is simply going to be P or, and when I apply the negation in this case, or I should say the De Morgan's law, I get negation of Q and R. Okay, I don't think I can simplify it further down. Maybe I can apply the distributive law, but I don't think it is going to result in any further simplification, right? So I'm going to leave this part over here, and this would be the simplification. Okay, moving on. Now this is going to be a very interesting and a tough question to solve, but just like I said, it is very important to have a good understanding about all the laws that we use, right? If you have a good understanding, or if you remember how all the laws work, then questions like these should be easy to understand. The basic idea of how to solve these questions is to identify where I can use which law, right? So I'll try to explain how I solve these type of questions, and I think it would be easy to understand. Okay, given this question, right, my first thing is I need to identify what kind of law I can apply, right? So if I try to notice this equation, what I find out is that there is some kind of a pattern which can be very helpful if I apply the distributive law, right? So if you notice, this part and this part are very similar to each other, right? There's a negation of P or Q, and there's a negation of P or negation of Q. So what I find out is maybe I can rearrange this logical equivalence and then apply the distributive law to it, right? So let's see how that works. So first, what I do is I do negation of P or Q and negation of P or negation of Q, and then I apply negation of P or negation of Q, right? So what I simply did is I brought this last bracket to the left hand side and then rearranged the entire equation, right? That's exactly what I did. So I'm going to write down the laws as well. Okay, moving on. Now I can apply the distributive law, so I get negation of P. I take the negation of P common, and then I do or Q and negation of Q. Try to make sure that you're using the brackets very carefully, right? If you remove the brackets, then it could be that you maybe miscalculate the entire equation, right? So I'm using the brackets to make sure that the answer is as clean as possible and I understand how I'm following the entire question. Okay, so I've applied the distributive law and then finally wrote down the entire equation. Okay, once again, I'm going to look for a pattern in this question, right? And the pattern that I notice is there's a Q and a negation of Q, right? This is basically the negation law, right? Q and negation of Q basically results in a false. So when I apply negation, I get negation of P or false and P or negation of Q, right? So this is the distributive law, and this is the negation. Okay, let's try to move down further. I'm going to move the answer to the top, right? So I hope you understand how this works. Okay, so I had negation of P or false and P or negation of Q. Now let's try to understand how to proceed further in this question, right? Let's try to take a look at this part. I don't think there's any law that I can use in this case, right? P or negation of Q. Maybe there is one, but I don't think that is going to be helpful to me, right? But when I look at this part, negation of P or false, I understand that there's a way I can simplify it, right? Since there's a false with the or in this case, then this is basically the identity law, right? Why? Because I understand that this false is not really important. The actual answer to this bracket or simplification depends on the negation of P value, right? So think about it. I know that in an or statement, I only need one true value. So the actual answer to this question depends on negation of P. So this gives me negation of P and P or negation of Q, right? So what is this law again? This is going to be the identity law. If I kind of understand it as the proposition is trying to maintain its identity, right? So I get negation of P. Okay. Moving on. Now, try to figure out a pattern once again, right? As far as I notice, once again, I can apply the distributive law in this case. So what I get is negation of P and P or negation of P and negation of Q, right? Distributive law again. Okay, let's try to understand the pattern once again. I see the negation law over here, right? Okay, one more point I missed is I forgot to mention the negation law in this case, but I hope you are able to understand how that works. Okay, I think I've mentioned it already. So once again, I'm going to apply the negation law, but I'm not going to mention it, right? But you understand negation of P and P is going to be false once again. And this is going to be false or negation of P and negation of Q. Just try to understand it one more time, right? There's a false with the or, right? So whenever there's a true with the and there's a false with the or, you should understand the pattern of how things are going to work. So since there's a false with the or, the answer is going to depend on this side of the equation, right? So hence, the final equivalence is going to be negation of P and negation of Q, right? Now, if I take a look at this equation, there's no further law that I can apply to it, right? And hence, I'm going to leave it to this part. So this is going to be the entire simplification of this equation, right? Now, before moving on, let's try to understand one more time, right? It's very important to understand that I have a good understanding about all the laws that we have, right? So for example, the commutative laws, distributive laws, negation, etc. I'm not going to say that there's a pattern to it, but as soon as you keep practicing these type of questions, the better you get at solving these questions, right? You're understanding those patterns. So moving on, let's try to solve the last question. Rewrite without the implication. Implication basically means this, right? Now, once again, I'll leave this question for you guys to solve and I'll add the answer to the description. But to give you a basic hint of how you're supposed to do it, P then Q is equivalent to negation of P or Q, right? So maybe what you can do is, instead of this arrow, this is what you're supposed to do. Instead of this arrow, you're supposed to represent the equations in this way, right? So once you have done that, try to simplify the entire equation down. And my basic hint would be, it would either be a true or a false value, right? So that's it for this lecture. and I'll see you guys in the next video.